All right, so let's just kind of get into it. We've had a lot of discussions today around AI, finding value in it, the implementations, and even some new ways to explore with AI. So I think, what we want to do here is cover that, but let's focus a little bit as well on data analytics, data science, which is, I think, your areas of expertise. So maybe I'll just ask each of you to introduce yourself, your background, your roles, responsibilities, and maybe something that you're working on right now that you want to share with the audience.
Yeah, sure. Thanks, Jim. Yes, so my name is Rebecca Nugent. I'm the head of the Department of Statistics and Data Science here at Carnegie Mellon. And on behalf of CMU and our department, along with the Corporate Startup Lab, thank you so much for joining us. Welcome to Carnegie Mellon. You came on a beautiful day. We're pretty excited, so hope you're enjoying yourself. So part of my portfolio outside of the department is a lot of workforce training programs. So you heard this morning about the AI Institute for Societal Decision Making. That is one example of a workforce training program that we're working on, trying to figure out how to build training exercises, programs, content, modules, you name it, we're building it for very diverse workforces that are going to need to figure out how to incorporate AI into their decision-making processes. And so some of the examples you heard about this morning are disaster management and public health, but we've done it for pretty much anything: manufacturing, agriculture, life sciences, finance. And so that is one section of my portfolio that I'd like to highlight, and very happy to answer questions about any of that.
Hello, everyone. My name's Ian Blunt. I'm Vice President of Advanced Analytics for Highmark Health. We're an integrated financing and delivery system, which is really a fancy way of saying we own a health plan and a bunch of hospitals. We've got some other businesses as well. And I've got more than 2 decades, I'm shocked to say, in healthcare analytics. Really think about how we can use healthcare data and the analysis of it to better understand how the healthcare system works and how it can be improved. And at Highmark, my advanced analytics group are a center of expertise for all things data science, AI, ML, and advanced analytic techniques. So we run across all areas of the business, trying to find ways that our insights and capabilities can help improve the kind of working lives of the people that work for Highmark and the people we serve.
Hey, everyone. Hello. My name's Chris Martin. I'm the Senior Director of AI at BNY. We're one of the world's largest custodian banks. We're kind of a little bit of a strange player in the financial services world. Most of us here potentially could probably not roll up to BNY and get some sort of mortgage or something like this, have an account. What we do is we really safe keep the world's assets and help to move money around the world. So what does that mean? So we hold in trusts about $50 trillion of assets for our clients around the world, and we also process a lot of payments and a lot of financial transactions to the tune of, at its peak, more than $20 billion a second worth of financial transactions. Why is that relevant? So when you talk about data, that is a massive amount of insight that we have around the financial operation of the world of the financial services plumbing. And I think that's, if we talk about it's the data stupid, to the subtitle of the panel today, this is a huge opportunity that we have to leverage AI as we want to be more for our clients and run our company better. We're America's oldest bank, BNY, founded by Alexander Hamilton. All sorts of random Hamilton tidbits that will get hopefully stuck in your head the next time you see the play. I'll throw at you. But this is also, it's a legacy of 240 years of innovation, and this is we would really want to be at the forefront of not just the application of AI, but the responsible application of AI, and that really again goes back to that central role that we play within the financial services world.
Okay, great, thanks. Rebecca, I'm going to throw first question at you. I know that often you always we always ask you to define these terms, right? Because I think, to have the conversation, we want to have some context on the terms, data science, analytics, AI. So maybe share, how you see them and how they intersect with each other.
Yeah, sure. So thank you, Jim, for that opportunity. and to do it without any sort of slides or visuals or props. So I'm pretty jazzed right now. Yeah, I think this is a really common question that we get asked, though, because a lot of this is sort of terms are bubbling up and becoming popular, and then they get applied to all sorts of things, right? So AI has actually been around for decades. I mean, it started in the 50s, really, what we kind of think of as AI. And data science and machine learning has also been around for decades, forever, but it's sort of becoming like popular now to say that things are data science and AI as we've moved into this heavy data, heavy computational space. And then we're trying to think about how to solve all these challenges, right? These real problems using these techniques and approaches. So when I think about data science, I think of it as the definition that we often use is to extract value from data to solve real world problems. And that is a very generic kind of phrase. And notice, you could unpack that in a lot of different ways. You could be using graphs to solve problems. You could be using robots to solve problems. You could be doing all kinds of different things with technology. But that's really what you're trying to do. I need to extract value from data to answer my question. And one of the things, I'm trying to gauge kind of the audience here. So who here, when I say the movie Twister, knows that we clearly mean the one from '96 with Helen Hunt and Bill Paxton? Give me, all right, this is my group. I feel good about this. Because when I talk about this at the universities, they all think it's this like one that just came out, this Twisters. I mean, like, hello. But if you think about Twister, so if you're like, where is she going? It's okay, Jim, I'm coming back.
No, I told you total curveballs.
Well, you gave me
today.
no props,
Yes,
so I'm doing Twisters.
Yes.
All right, and now I'm watching her. She's doing, it's okay to do a tornado. We're going tornadoes. Okay. So if you think about it, if you haven't seen the movie Twister, the whole point is they want to develop an early warning intervention system, right? So we want to better understand how tornadoes move, how they're formed, how they're being modeled. That's our research question, or our business question. That's the first phase of data science. We have absolutely no idea how this happens, and so we need to collect new data and figure out how to get information about these tornadoes. And there's no way to do it. And the way they figure out how to do it is that they're going to build these little these little balls that fly up. They need them to go up in the tornado, grab the signals up there, grab all the data. That's actually the data engineering. That's the data technology. That's the data acquisition part of data science, which is the second phase. And then all of that data is coming down into the statistical models. And if you remember, they're screaming at the end of the movie, right? They're screaming, we've got the data. So the data scientist is the heroes, like we're the heroes of the movie. And it's coming and it's forming here's what the tornado looks like. And there's an interface and the tornado is modeling and everyone's screaming and they're super excited. And, cows are flying. Those are the stakeholders, right? And then finally, when you think about dissemination, right? That's the last phase of data science. And so that is, we take all of these results and models and information and we're going to turn them into something actionable. We're going to disseminate to our stakeholders. We're going to save the cows, right? We're going to do all of this. Those really are the 4 phases of data science. So business research question, data engineering, extraction, acquisition, how are we going to collect it? Where are we going to get it? That's a lot of infrastructure there. Coming down into the AI is part of that too, coming down into the AI modeling, machine learning kind of section of data science. And then over into the communication, dissemination, how do we build a human interface with those things as well? So for me, I think of AI as being part of the data science lifecycle, right? You can use something with AI in this larger question. You don't have to, you can. And AI is trying to use technology to help humans make decisions, right? It's extracting information and data. Machine learning is like a set of algorithms that's being used for very heavy computation on lots of data. Statistics is thinking about foundational inference questions. I'll tell you now, statisticians are pretty mad about all this stuff because we were like, we've been doing this forever. Like, why on earth is everyone giving them all the money? That kind of thing. And when we think about data analytics, that's a phrase that gets used quite often in the business world. And we, in statistics, data science, we sort of laugh because we almost never use it, right? So we think of data analytics as describing, summarizing, or modeling data once you have it. Yeah, but data science is that entire tornado piece, right? That's the entire life cycle. How was that?
No, that's great.
Is that okay?
I cannot wait to see the other side of that flip
That is what
chart.
I'm talking about.
Oh my goodness.
The
It's gonna be-
tornadoes,
yeah.
there's flying cows, tornadoes. I just thought we'd do a challenge.
Okay.
All right, thanks.
Ian.
As someone with like real world experience of trying to find the right data that you need within an organization, it does feel like going through a tornado at times. I also really love the definition of data science as a process, because I think that's so right. It's not your mastery of XGBoost or any particular method. It's about how you're able to take a real world problem, deconstruct it into its component part, the way it's tracked in the data, and then apply some kind of algorithmic approach to extract insight, and then critically deploy those insights somewhere where they can be of use. I thought it was a wonderful description. Also, like for snappier ones, I've always loved a data scientist is someone that knows more statistics than the average computer scientist and more computer science than the average statistician, because that kind of sums it up. And I think the terms like one brilliant description I heard, like they asked, it was on a podcast, they asked a university professor in the UK, can you say what artificial intelligence means? They said, yeah, it means a really poor choice of words by someone in the 1950s, because it's so just vague, and at the moment it's a real
From
buzzword.
Stanford, I believe.
Yeah.
Stanford.
It's so yeah. I mean, one of the things we've tried to do is move within Highmark is try to move our business partners away from these like vague, buzzy terms like artificial intelligence, machine learning, data science, back in the day, big data, and get them to focus on what's their problem, what's your business problem. Forget about like how we're going to solve it. Just like, what are you trying to achieve? And then I've got a team of people that can work and select the right method. Maybe it's a data science problem, a generative AI problem, traditional AI, maybe it's automation. But the key is like focus on that need is the main thing we do.
Yeah, I appreciate that comment about artificial intelligence being a kind of a misnomer or a bad phrase that got coined a long time ago. We keep hearing that, like it's getting worse and worse because it's very misleading. I've heard augmented intelligence actually being maybe as an example of a better way of AI. Maybe some of you have heard other terms, but it's not actually artificial intelligence, right? So maybe we can do better. Chris is over there blaming other people, like other universities. But
Again, the science born here and the marketing comes from the West Coast, so poor as it turned out.
you put that in
Yeah. Where's Dave Mawhinney when you need him? I mean, Chris just gave him a perfect setup line, and we Hey, Jim, where'd you go to college? Yeah, we won't talk about that. But I will make one comment about what Rebecca said about, what was it that data scientists never used the term, was it business analytics or no?
Sort of, or the phrases predictive analytics, prescriptive analytics. I have so many statistics and math degrees, it's kind of ridiculous. It would never came up in a single class. In not one statistics or data science class did we ever use those phrases. It's just different terminology. There's nothing wrong with the phrases. It's just we just don't use them.
I was just going to say, that's like someone who lives in the Northern California, the Peninsula, Bay Area, and they don't call it Cali. They actually don't really call it Silicon Valley. So that's kind of my equivalent. All right, Chris, back to you.
What do you want me to say?
I don't know. Add on to Ian, Rebecca about terminology, or take it in your direction.
More dunking on Stanford. I'm a very proud CMU alum, by the way, so it's always fun to make fun of our friends on the West Coast. So if you look at the title that's on my name tag here, we also talk about responsible AI, so really doubling down on this vague keywords. But I think a little bit of what does that mean? And we're also trying to make that as concrete as possible, and it's something that we're also interested in collaborating with Carnegie Mellon in terms of what that means. And so let me give a very practical example, of what this means. Let's say at BNY, but I think it's also potentially relevant for many organizations. So we have like I think many organizations, you just don't open up things like ChatGPT or whatever up to all of your employees, so that you can sort of do whatever you want. You have, because in terms of like data loss, or you want to understand how people are using these things. So our platform is called Eliza. So if you hear me talk about Eliza is Alexander Hamilton's wife. So I hope, just like you, the next time you go and watch the play Hamilton, and Eliza is very loudly introducing yourself, you think of BNY's AI platform. I guess that's probably pretty unlikely. But the point of this is that through ELIZA, then we are able to, we have this control plane that allows us to understand and empower our employees on how they use AI through these tools. And what is the responsible AI part of that is really, it starts right at the very beginning with that data part. I think that's probably maybe not the first part of the tornado, but the second part of the tornado that was referenced earlier. Because there is, as I mentioned earlier, because of our position, in the market, there is a ton of data that we have access to. But just because you have access to it doesn't necessarily mean that what you want to do with it is appropriate for either for your role or for what the opportunity you want to pursue. So right at the very beginning, it's one of those kind of like, this is the first part of the like, don't build Jurassic Park, kind of thing. The scientists never, what's the line? They just only thought about what they could do, not about whether or not they should. So we think about that question a lot right from the very beginning of the data. So there's from legal, data ethics, compliance, folks like that right at the very beginning that say, wait a minute, what do you want to use and why do you want to use it? And then there's kind of more, or I won't get into the whole life cycle if I can kind of talk a little bit more about that later on. But that's very practically about when we talk about the responsible usage of AI or responsible AI. It's really grounded right from the very beginning, right from that ideation, early stage innovation day, much less till later on, which is also a whole different ball of wax. But I think that's something that we can all think about a little bit. It's not just go out there and scrape a bunch of data. Again, let me just give one specific example about it. Is a lot of us, you think about like, oh, I'll just, ChatGPT is great for like summarizing news articles, or what does this mean? That's not necessarily what the license allows. I mean, for maybe you as an individual, but certainly as a company. Like, I want to compare the Bloomberg article to the Forbes article. I don't know, whatever. That's not what is allowed by the terms of use for a commercial usage of that type of thing. So that's something that we also want to really lean in and say, listen, that's not an allowed use for our AI platform at BNY. Is it a pain? Does it slow things down? Absolutely. Is it our interpretation of the right thing to do to honor the licensing agreement associated with content creators? It is. So these are the pluses and minuses of like, oh, let's just go rush ahead and build Jurassic Park. Well, you know what? Maybe we should think a little bit about what happens when we're making the little dinosaurs as they start running around the island.
Ian, you're going to have to pick a movie now. We're going to be movie themed.
I'll work on one, definitely.
That was totally not on purpose. I didn't even think about that.
I mean, I think that's right. And so on the theme of scaling AI, the latest generation of large language models offer huge potential to scale because they're so much more accessible. But they also carry a lot more risks because they're a lot more accessible. So if you're going to do a traditional AI model, you need to know a decent amount of code to get started. You can do horrible things with that. You still need process, but there's, every chance that you're familiar with the kind of process that Rebecca laid out earlier. There's a kind of degree of inherent responsibility. Because the large language models are natural language, anyone can pick them up and use them. That means suddenly we need to take AI ethics, responsible AI, to a much broader segment of our workforce. And we took exactly the same tactic. We don't have a Broadway musical about our founder, so we called ours Sidekick. But that's just it. Everything we heard from our business partners was, just let me use ChatGPT. I want to use ChatGPT. It's so easy. And we're like, it is easy, but it's also easy to like really mess up with it. So what we need to do is harness that capability in a secure environment, so no data leaves Highmark. It's all within our stuff. We can place boundaries and guide rails on it, so we can say, well, that's not an appropriate thing for us to answer. But we can then give it out to all of our staff and let them use it to find their own productivity boosts, fix their own processes. And while they're doing that, watching how they're using it and using that as a way to build a backlog of new features we can put in that enable people to do even more with this technology.
What about from a use cases standpoint? Maybe this is for the whole panel. Use cases that you've seen where you've gotten value, or maybe areas where there's still some constraints or things that keep you from getting there. jump ball.
Do you just mean use cases for data science in particular, or
Yeah, I
something
think
specific to
yeah.
responsible AI?
No, I think data science as applied to, of course, now I'm worried about using the right terminology, but just kind of this general discussion.
Your panel already talked about tornadoes and Jeff Goldblum and dinosaurs
All right.
and Hamilton, so I feel like everything goes now.
Yeah.
I guess I dropped. Well, that was a play before it was a movie, I suppose. But yeah, I mean, just a little bit about sort of framing different use cases as well. It's a bank, right? So we spend, I don't know, I bet you 110% of our employees spend a decent amount of time thinking about risk. And so when we think about the risks of applying technology, I mentioned like the large amount of data that we're processing in terms of these payments. There's still a lot of manual touch points that go along with this. And so if we think about, and when I say manual touch points, it's humans. Humans are going in and fixing things, and let me process that or whatever. So, and humans are also risky, not in terms of the Abhinav and Deepak, like dull, dirty, and dangerous, but like, you get tired, you transpose a number, this kind of stuff. And so you kind of, the way that traditionally that you fix this is you get 2 eyes or 4 eyes or 6 eyes, going on with this. But even then, it's humans on top of humans, probability and all this stuff. Actually, I shouldn't use the word probability just off the cuff in front of the professor here. But the point of this is that now this is the opportunity to have a little bit of a discussion around, when you introduce these type of technologies, which are transformative, how do you properly understand the risk of something like a large language model? And I'm talking about that because it's both incredibly powerful, but it's also not really fully understood in terms of the performance envelope of these things. So on one end, you want to rush out and apply this thing, like, look, I'm gonna automate this, or I'm gonna remove this step of where humans will look at it and do that kind of stuff. Potentially, but then also, is this really the right technology that we wanted to apply, because it is not very well understood? So just again, to come back to your question, Jim, around like the set of use cases, I think there's a lot of opportunity around automation in this sense, and done right, we can potentially reduce risk, and I can talk specifically a little bit more about some of the ways that we're seeing that. But done wrong, this is again the responsible AI part of it. It's not just let's throw a black box piece of technology at this, and we really need to be incredibly well understood, and you also have to be able to evidence that within a highly regulated industry, financial services, healthcare for sure.
Yeah, that's absolutely right. And if you think about the way we do responsible AI, which actually is wonderfully consistent across traditional AI and generative AI, all the same things about ethical risk assessment, what's the use case, the data we feed in, are all still true. The challenge is that outcome monitoring. So in the case of traditional AI, if I'm predicting the likelihood of a certain event, great, I can measure that event. I can say how accurate my model is. I can say whether that's fit for the use case. I can monitor it continuously, so I know if it started to drift. If it's unsupervised learning, so I'm putting someone in a particular cluster or segment, okay, so there's no ground truth for that. I can I can ask people's opinions on it. But the good news is it can't go too badly wrong, right? I've only got 5 clusters to choose from. The risk with generative AI that I think we've seen is it can make up a totally random response, because at its foundational model, it's got the entire public internet in there and everything that's ever been said. And we've seen some really interesting stuff when people are able to use that as a vulnerability, and you can start getting the Gen AI to ignore its prompting and do something else. So how do we do those kind of controls? It is absolutely possible. It's a rapidly developing area, so we're going to see more things coming on month by month. But one of the big criticisms you'll hear about generative AI is that it's really easy to make a proof of concept. It's very, very hard to get into production. That's undoubtedly true, and it's because of issues like this. We mentioned about automation and standing in place of where a human would have a touch. I've seen a lot of, we'll call them production Gen AI use cases that are basically decision support. I will prepare something for you, I'll draft, but human being, you still need to review it, which in many cases makes perfect sense. It is a bit like the early days of the motor car when they had a little guy with a red flag walk in front of them. to limit them to 4 miles an hour, whatever it is. So it's good, it's useful, it keeps everyone safe, that's important. It's not sustainable. So we need to solve for that confidence piece of letting the generative AI go and like directly produce some insight, and then as we start to think about AI agents acting upon that insight as well.
So I'll offer some use cases that are different from finance and healthcare, just to kind of give a broader range. So for example, if you think about sports analytics, so Carnegie Mellon is one of the biggest sports analytics groups in the country. What are you pointing at? Oh, I thought you were pointing at the wall. I was like, yeah. Anyway, so we have a Carnegie Mellon Sports Analytics Center. Our annual conference is next weekend, actually, if you're around. But we work with lots of professional sports teams and related organizations, and so you can imagine the things that we're able to do now with the data that we are collecting all the time. So now it's not just here's a stat on how many, percentage completion or, wins and losses and things like that. When somebody is throwing a ball, right, towards somebody else, we have all of the tracking data on where they are, where everybody else is. We have their direction, we have their speed, we know which way they're going. The ball has sensors in it. We know the speed, the angle, et cetera. We can track it as well. We have the data we're not allowed to get is a lot of the medical data that's being tracked as well with the players. So it's an incredibly complex world now, but it's an awful lot of fun. We can do all sorts of analysis that it's not just about. I want to be clear. The teams are asking us to help them win. I mean, let's be honest. But we're also getting asked questions like, can we optimize training? Can we optimize practice? How many reps of a particular group? When do we stop? How do we prevent injuries? Let's look at that we put sensors in the helmets and we look to try to understand head injuries, concussions. Can we keep people safe, right? Can we do these kinds of things? And it's not just the major United States sports that you might think of, the main ones, kind of the basketball, the football, the baseball. That's Moneyball, next movie. Mm-hmm. There you go, next movie. It's not just those, but we work with esports, we work with cricket, we work with figure skating, we do things with the United States Olympics. Whatever you can think of, we're collecting data and information on it. You guys, the Olympics that just happened, Kate Douglas, anybody watch Kate Douglas swim and win tons of medals? Yeah, I've got some nods. Doing her master's in statistics, doing research paper on swimming data. The UVA team that knocked it out of the park and brought so many medals home this year for the United States swimming team. One of their staff members is a math professor at UVA who analyzes data about, they are leaps and bounds ahead of all other Division I college teams in terms of that. And they're just cranking out medals left and right because they're doing such an amazing job. So again, not just about the wins and the losses and the medals, but we also use sports analytics and the data that are available to get kids really interested in STEM things. So we do an awful lot of, can we build educational tools and show them data and get them excited about learning about sports and data. We kind of sneak in the data science and the statistics when they're thinking about learning about sports. And we see that we can build pipelines with pipelines with under-resourced communities and all sorts of things by using the kind of data that get collected all the time, right? We can help K through 12 start discovering some of these career opportunities that they might have or thinking about doing degrees in this space. And I'll just finish with my first meeting this morning. I was so excited about, and they have no idea I'm getting ready to say this, so look them up. It's a company called Vooks, Vooks, so books, but with a V. And they use AI to animate beloved children's books. So imagine a Curious George, right, that everyone reads maybe with their children, but they have an interactive version of it where the illustrations are moving and animating while the book is being kind of read out loud. And they're tracking data. The kids are talking, the grandparents are talking, all of this is being recorded and tracking, and we can track how do kids learn how to read? Can we help them learn how to read, et cetera? The percentage of K through 12 that's failing kind of reading literacy is just, as I'm sure you've all seen, it's devastating news. And so how can we do a better job, right, of collecting data and information about something like kids reading Curious George books, but have that help us use ed tech, right, to turn around and like push fluency and literacy at a very young age. So those are some different kinds of use cases. Then, yeah.
What's going to come first, self-driving cars, or you're going to help the pirates win?
Self-driving cars are what?
You're going to help the pirates win.
Okay, so I'm on a mic right now, so I can't talk about all that, but
All
you can
right.
catch me in the hallway, and we can talk about all kinds of
So-
things. And I'm sorry, I just want to say, Jim's like, Rebecca, our sports analytics conference is next weekend. It's huge. It's sold out. And you cannot at all, in any way, shape, or form, email me to get on the registration list. I want to be very clear. Okay, thank you.
I would love to keep talking about baseball analytics at the happy hours, but in the interest of time, I'm going to ask the panelists one quick question that wasn't on the script, and want a short, sort of lightning answer, right? So if this talk is, it's about the data stupid, right? And I actually heard, I think some of you talking about this yesterday, that like, gosh, I would rather have good data than, this. So fill in the blank. I would rather have a great data set, and however you define it, than this. And I don't mean your Netflix account, so you can watch movies, but I mean like, what's the trade-off? Just give us a sense for how important that is.
I would take a great data set and basic, robust, simple models over anything ever on the planet Earth related to this. Now, I'm not referring to my children. They take precedence, but that, I'll just stop there because it's supposed to be quick. That's the priority.
Yeah, it's the data. Like, I saw a wonderful T-shirt at a conference which said, "You don't have an AI strategy if you don't have a data strategy," and that's so true. And when you're in industry, most of the life of a data scientist isn't the methodology. That's the fun bit. It's what we like. Most of it is understanding the problem, finding out where the data get recorded, or sometimes implementing the recording of that data, so then you can go and do the fun bit that you enjoy, so then you can produce the outcomes that you need. So always, like, number one, get them to define the problem. Number two, find out the data associated with it, because that is your key. And also understand the data. Like, the best way to do that is watch whoever enters that data, or watch it go be collected, basically. Because I've seen so many people fall down when they take a data set with column names and they assume they know what that means. No, you've got to understand what's going through someone's head when they type it into that box of their user interface. That will give you much better solutioning around solving the problem, and much better insights that you generate.
And Chris, take us to Q&A.
I would just, I'm not sure where I'm supposed to fill in the blank here. Then after Rebecca said everything on the planet Earth except for children, but I think it just goes. In terms of the data quality aspect, is with all of this focus on AI, let us not forget about the humans that are ultimately driving that data quality portion of it. I'm really proud to work for BNY, 50,000 people, or my colleagues across the planet. Pittsburgh is the largest site anywhere for BNY employees, and it's not by accident. It's also the site of the largest AI team here. And so we work on a daily basis with our colleagues that are on the front lines of this. And so really trying to make sure that we're on the same team, because they're the ones that are out there processing, operating, this data, helping us understand the opportunities around it, and it's sort of a little bit of that, like, we're not here to automate your jobs, off the planet. We're here to work together with you around the word around augmentation. Let's not forget to appreciate and to incentivize the humans that are making all of this sexy stuff possible.
Great. Time for maybe a couple questions.
I'll ask a question whose intent is to explore or maybe even unearth the differences between data science and machine intelligence or AI. I heard it said that the term predictive analytics, for example, is not used in data science, as well as another term. In my own experience, I've heard or used the terms predictive analytics, prescriptive analytics, causal analytics, descriptive analytics. and comparative analytics, and maybe there's some others that are not. And cognitively speaking, the reasoning that people employ in each of those is very different. Mm-hmm. And if you want to automate it, then the algorithms that you use are all very different. So if data science doesn't employ those terms, do they use other terms, or is the view of the world of data science different than machine intelligence, or maybe you can...
Oh, sure. No, and thank you for asking that question. I think, so my take on that, and maybe there's a slightly different, but my take on all of those things you listed are they're actions that are happening in data science. It's just the terminology is not something that's typically said in data science training, and if you think about traditional courses in statistics and data science. Yeah. If you're over in, say, the tech business school where we are now, you might hear those kinds of terms being used more. But it's not the absence of that. So I guess what I would say is if you took a kind of a machine learning class in my department, you would be learning different kinds of models that would try to capture the kinds of reasoning that you're talking about, but we wouldn't assign them a label of like, this is the model you use when you want predictive analytics, and this is the model when you want this kind of thing. We would take it from what Ian's perspective is, which is start from the problem. What are you actually trying to answer, and kind of work in developing a model strategy using that. So it's not sort of let's label it into a box, right, and then pick models out of that. It's based on everything's defined by the problem, and so then you just learn a class of kinds of models and kinds of algorithms that you try to then figure out what's kind of the most important thing or like the best match for the outcome that you're interested in learning about. I think one of the things we often caution people about are so many of these models and things, the packages that people are using are very like, we're going to try to, Sean Ammirati actually said this pretty nicely the other Tuesday night at a panel was, you know, we're going to predict, right? And then we're going to classify, and we're going to, like, we have all these kind of outcome driven things that our models and AI do really well, but they're all, what I would add to what he said is, they're all based on like historical data, and they're going to continue just to predict the same kinds. Oh, I guess you did talk about that with a case study from Amazon. That they're just going to keep predicting the same kinds of behavior. So if you want different behavior, you know, if you want a different kind of outcome where you have goals and principles and innovation for your company built into that outcome, then I wouldn't use just a standard prediction model, right? I would have to build something that's going to allow me to put in goals, put in rewards, put in penalties, put in here's what I'm aiming for, and let algorithms optimize toward that instead of just saying, I just want to keep predicting the same kind of stuff that we've always done. So, but that case, it's all problem driven, right? And so I'm picking a model that's a good match for that problem. I don't know if you guys have thoughts on that. That's my take.
Yeah, I'd agree. I think you do see the descriptive, diagnostic, predictive, prescriptive model. It's quite a handy way to expose lay people to how they're going to interact with the insight, and in a slightly prejudicial way kind of describe the background of the people that are going to provide that insight. So when we're talking descriptive, that's just like, get me the number, and then as a business person, I'm going to do something about that number. So to get a number, I really want to talk to the people that own whatever system is producing the number and just get it, represent it. The diagnostic stuff, then you're saying, well, why is that number that number? Okay, so now I've got someone that's a bit more analytically minded. I'm thinking about kind of slice and dice business intelligence. How do I unpick that number? What skills do I need there? And then obviously making predictions, you're starting to think about people with a bit of data science training. They can build these predictive models. And then for the prescriptive part, it's someone not only has that data science background, but also the data engineering, maybe software engineering skills to then go and transmit that number to wherever it needs to be, or that insight to wherever it needs to be to cause some kind of action. But as you get into like the methods for data science, actually you start to see that spectrum breaks down. So I can do some really good diagnostic work, like explain why a number is a number using machine learning techniques. So yeah, that's why it's useful in some contexts, but it's not absolute across all dimensions of AI, I guess.
Yeah, and to be clear, I think that's actually what I just said about how you wouldn't see that in other classes. I'm not saying that is a good thing. Like, I think it's actually a problem that the data scientists that we turn out of our programs have not had enough exposure to the type of language that other people would be using in solving their business problems. That creates some of the communication issues, right? So we want to really focus on the business people need to learn to communicate with the data science AI people, and the data science AI people certainly need to learn, right, how to communicate with the non-data science and non-AI people. I think one of the things we're seeing in a lot of the public polling now, just in lots of studies that have come out in the last 4 to 6 months, the public perception and like the desire to adopt AI in particular, there's backlash brewing. I mean, I think the Pew Research is over 50% of adults are now more concerned about AI than they are excited. CNN just did a story a couple months ago on a big piece of marketing research that across every single sector, this is a study that came out in a journal, every single sector, when they showed high-tech marketing versus AI marketing, high-tech branding performed better than AI marketing. And we're seeing the same thing. I just came back from an event in Germany, and their leaders were saying the exact same thing. People are pushing back. We're all super excited about this stuff and jazzed, and we live in this kind of bubble. And there are literally billions of people on this planet who do not want to deal with like AI and data and all of this stuff, or they're nervous, or they have some perception of it that's incorrect. So we need to be spending a lot of time on communication, I'll say. And that's kind of what you were saying with like thinking about the humans and the humans first and foremost. Yeah, people first.
I think we have our last question from that side of the room.
It's a good one to wrap up on, I think. Thank you all once again. Insightful and fun. I'm really curious if you guys have seen any good movies, because the ones
Well, that's kind of harsh. I
Jurassic
felt that
Park's
was kind of
movie.
like
Moneyball's a
good movies
Perhaps-
about AI
perhaps
data
some-
or just in
perhaps
general.
some West Coast recommendations on film selection. I don't know.
Interesting. Chris, I'll let you take the West Coast part. I'm going to sit over here but think about movies. Ian, I don't know which one you want to take.
Yeah, that's right. They do make good beer. I mean,
All right. Well, hey, Chris, Ian, Rebecca, thank you. Thank you for a lively discussion. And actually, I have just one last thought. I mean, as we were talking through it, I was thinking, what part 2 of this discussion is going to be called "It's the Problem, Stupid," and because I think that's really the other thing that I've heard constantly in all of these conversations. It draws back to the problem, and I know even with startups, people ask me, "What's a great idea? How do I come up with a great idea?" I said, "Figure out a good problem to solve." So I think there's a lot of ties here.
and I can't actually. There is not a movie, but the book Big Data Baseball is about the 2014 Pittsburgh Pirates and how they tried to lean into this and it didn't really work out. But anyway, so it's not a movie, but it is a book.
Yeah.
They tried. Well, I just love that stupid team.
All right.
Rebecca, fix them, please. Counting it.
On it, Chris.
All right. Well, thank you very much.
Thank you so
Hey,
much
all
for
right.
joining us today.